Have you ever wondered why a giant ship can float on water, but a tiny pebble sinks straight to the bottom? It seems almost magical, doesn't it? But there's a fascinating scientific explanation behind this phenomenon. It's all about a force called buoyancy. Buoyancy is a force exerted by a fluid that opposes an object's weight. This force is what allows objects to float or sink in water. Buoyancy is what makes things float or sink. When an object is placed in water, it displaces a certain amount of water. The displaced water creates an upward force known as the buoyant force. Some objects are buoyant, which means they can stay afloat. This happens when the buoyant force is equal to or greater than the object's weight. Others are less buoyant and sink. If the object's weight is greater than the buoyant force, it will sink to the bottom. We see buoyancy in action every day. From boats gliding on lakes to swimmers floating effortlessly in pools, buoyancy is all around us. A rubber duck bobbing in the bathtub, staying afloat because it's less dense than water, a hot air balloon soaring through the sky, lifted by the buoyant force of the hot air inside it, even a fish swimming in a pond. These are all examples of buoyancy at work. Fish have swim bladders that help them control their buoyancy. But what exactly causes buoyancy, and why do some things float while others sink? The answer involves the density of the object and the fluid it is in. The answer lies in the science of water and the forces that act upon objects submerged in it. When an object is less dense than the fluid, it floats. If it's denser, it sinks. Let's dive in and explore the fascinating world of buoyancy. Understanding this concept can help us appreciate the wonders of physics in our everyday lives. Thousands of years ago, a Greek mathematician named Archimedes discovered a principle that explains why things float. This principle, now known as Archimedes Principle, states that an object submerged in a fluid experiences an upward force equal to the weight of the fluid it displaces. Imagine you have a bathtub full of water. When you get into the bath, you displace some of the water. The water level rises. Archimedes' principle tells us that the weight of the water you displaced is equal to the buoyant force acting upon you. This buoyant force is what makes you feel lighter in the water. Boats, despite their size and weight, can float because of buoyancy. They are designed to displace a large amount of water. The shape of a boat's hull, the main body of the boat, is crucial. When a boat is placed in water, it pushes aside a large volume of water. This displaced water creates an upward force, the buoyant force that acts against the boat's weight, which is the force pulling it downwards. As long as the buoyant force is equal to or greater than the boat's weight, the boat will float. Section 4. Submarines diving deep and resurfacing with science. Submarines are fascinating vessels that can both float on the surface and dive deep underwater. These incredible machines are marvels of engineering and science, designed to explore the mysterious depths of our oceans. So, how do they manage to control their buoyancy? The secret lies in their ability to manipulate their density. Well, submarines have special tanks called ballast tanks. These tanks play a crucial role in the submarine's ability to dive and resurface. These tanks can be filled with either air or water, allowing the submarine to change its overall density. By adjusting the amount of water and air in these tanks, submarines can control their buoyancy with precision. When the ballast tanks are filled with air, the submarine becomes less dense than the surrounding water, causing it to rise to the surface and float. This process is essential for the submarine to resurface safely. To dive, the submarine releases the air from the ballast tanks and fills them with water. This increases the submarine's density, making it heavier than the water around it. This makes the submarine denser than the water, causing it to sink. By mastering this delicate balance, submarines can explore the ocean's depths and return to the surface with ease. Section 5. Ice cubes. Why do they float in your drink? Ice cubes are a common example of how density affects buoyancy. When you drop ice cubes into your drink, have you ever wondered why they float instead of sinking to the bottom? Ice is less dense than water, which means that a certain volume of ice weighs less than the same volume of water. This is due to the molecular structure of ice, which forms a crystalline lattice that takes up more space than liquid water molecules. This difference in density is why ice floats. The unique arrangement of water molecules in ice makes it expand and become less dense as it freezes. When you drop an ice cube into a glass of water, it displaces an amount of water equal to its own volume. This displacement is a key factor in understanding buoyancy. However, because the ice is less dense than the water, the weight of the displaced water is greater than the weight of the ice cube. This principle is known as Archimedes' Principle. This means that the buoyant force acting on the ice cube is greater than its weight, causing it to float to the surface. So next time you enjoy a cold drink, you'll know exactly why those ice cubes are bobbing at the